Hello everyone. Thank you for tuning in. Today we had a little bit issue with our internet. Uh, I was talking a lot with Christopher, but that's through WhatsApp thing. We had a problem with our internet on this StreamYard. So I just want to give a thumbs up, a few details. That's all. And you see that this is our T-shirt that I'm wearing, and then many people come across given the teachers, they are quite interested. And like we mentioned with last week, our trip was very successful, and we plan to right now publish in Journal of Nuclear Physics the in person, and we hope to do the same with the part two publication later on with the hybrid presentations, and then eventually come up with the book, that gives each of our research work. So I just want to give a brief overview of what we are doing and developing things, about quantum gravity that I have found, come up with the spin spectroscopy that I mentioned in our the conference also, and then continuing further to develop more general Hamiltonian and then discrete Lagrangian to describe that. That's just ongoing research. I hope to publish that, especially with the discontinuum physics that I'm doing with Emery Taylor. We are developing that, and also discontinuum gravity that we plan to publish in a few months, and then so these are all developing, and the project is developing with Lasto, planning to do some more gravitonic physics, and that combined eventually with Emmanuel's work. But our thing is our different, piece of puzzle. So eventually, we see if there is any common point. We come up with a theme that is common and will help to unify things, because there are things that's all spread out, and we want to bring them together as a unified physics type of thing that explains it in a more. So, what are things recently I found that on a general sense that the observations are important. We look at from first getting the physics and then the math. So, so the observations we have, like even now the telescopes are giving us new things. So those are the observations, and we have to take them the way it is. They give clue to the physics, and but that we have to, each person then looks at that and develop their own model. So that's the physics. And then we have to get a hint, like I mentioned about the CERN. They are put together like a double helix thing, all the equations of the standard model that eventually came the Higgs boson. So again, we have to put in a pot, uh, the math pot, so to say, all the hints that we get, out of that. So we have first the physics from the clue of observations, and then the hint uh, that we had from the physics, and also all the equations that we conform, and then we get the math. Then eventually the idea is that you just ask the question: is there a algorithm of the universe, or a universal algorithm that eventually is guiding it all? That's a very good question that we can eventually follow, but we are still in the way to figure out the components of that. uh, we have both the rules and the equations, uh, the rules of the number theory and the equations of algebra. Then we combine together. Like, for example, I mentioned about the functors. Functors are different, different elements that are, categories. So it's a categorical theory, part of a categorical theory that even IT is using. So they are separate. They are held by rules, only rules. But when they come together, the rules then as functionals by random fluctuations, things like that, they form equations. You can form equations of the functionals. But then you put the rules and the functionals together, the rules uh, of the functors and the equations of the functionals together. Eventually, they form function, which is essentially a flow, like a circuit or microcircuit that happens. And then they down you can do the correspondence, from the small to the big. So it's step by step. But when they are in categories, and that's the problem we are facing. Like in superluminal thing, they remain as categories. So we cannot come up with a function that will describe it all. Okay. So this is the idea of algorithm. Algorithm means that not necessarily you have to have function that will automatically transfer the quantum level to the astrophysical level. So we may not have that with the function, but instead we'll have rules and the equations, and then we put them together. Then we get functions which has correspondence as right, which may means that you may have a correspondence with the quantum to the gravity level, for example, of general relativity, things like that. So which means that the algorithm in specific conditions will correspond to eventually to general relativity or quantum physics. And this algorithm, essentially we are discontinuous physics aspect that I work with the Emil Taylor also. So it could be a subset of that. So this is the idea coming, but we have to have mathematics at all level to describe the quantitative aspects. Uh, Graviton is one such element, right? Quantum gravity, most important aspect now that even Emmanuel, the experiment we are trying to do, and I'm proposing some experiments eventually in some papers and proposals eventually that will figure out graviton, not just from CERN, but there are other experiments, spectroscopic measurement, electron spectroscopic measurements, and even scanning tunneling microscope, scanning probe microscope, different types of ones that will talk about the Borman electron or how the Thomas precision changes the quantum relativistic aspects, as well as the quantum wavelength, how they change, how they, you can interlink them, like Emmanuel has shown how the graviton thing, is connected with photon and electron. And we also have, from a different point of view, uh, how they come together. So they may be all part of that one aspect, that different phases look at that, and uh, and then we can figure out how these categories come together in the form of the functionals, and then how the functionals then join together and form the function, which is the flow, which the real universe. Our body is like that. Our mind, it works differently from our body. Right? That's the idea of consciousness that people are trying to develop now. So our mind and body are, the mind can be considered like a field, you know, and then the body is the matter uh, that the field creates. And then, of course, the religious aspect, eventually become souls. So this is the idea, and the physics, developed from the metaphysics that even Laszlo is interested in. Many of us are interested in the metaphysical aspect as well. There's a connection between metaphysics and physics that, Aristotle, for example, started with the metaphysics, and then eventually came to the idea of physics that we had to observe to create an objective picture of the whole thing, not just a subjective aspect. So this is the science that is developing continuously with the hypothesis, and then we develop the, we test the hypothesis, and continuously, we are changed based on our observations. That's how the natural sciences has developed, in different areas now. The genetics, for example, has proved is work. But there are a lot of things, missing aspects that we are still solve. So it's like we are converting what are originally the paradoxes into puzzle pieces. But then puzzle pieces, how they together, is again a complex issue, and then we have to figure out how. that can create everything together. And we don't know yet how to do that, or is there a final way to do that, or they remain separate? Can we develop an algorithm of the unified algorithm of the whole thing? So those are questions still unanswered. I don't know whether there is such a thing or not, or the whether graviton will solve this problem. But we have to, they show promise, and that's the important thing. Each research shows a promise and a way parameters and things that we can eventually measure, and that measurement is important aspect. Because once we measure that, only with proper instrumentation development into that, then only we can say, okay, this theory has validity, or this hypothesis has validity and becomes a theory. So, and a model, and this but more on a practical scale of matter. We are not dealing with absolute things, but real matter. And then again, you have to develop and the model, ITC model that developed does help to measure things. So the models and help to you know uh, eventually describe everything and also reduce the number of experiments we have to do. So we come up with critical parameters, variables, all idea. But the model has to be holistic, has to have logical sense, and it has to make consistent. So that's the math that develop, and the assumptions and other things can reduce the power of the model and the questionable aspects, right? So more and more there'll be a assumption, of course, but that has to be kept to the very minimum that eventually can be justified. I think that's what I learned from the modeling aspect for the IPC model, the electrochemistry, that we had an assumption, very important to come up with the mathematical quantitative, but eventually you have to reduce the number of assumptions, and whether we can have zero assumptions is an open question. So the same way, the physics also I found very similar thing that we say speed of light is constant, or all this habit constant, everything is constant, but are they really constants or changing? That question is very important. Over a period of time, everything could be dynamic. So we have like Euclidean helps to some degree, but we have to go to Euler because the dynamically the coordinates themselves are changing. So all these are important thought processes that helps us, what we call thought experiments that helps to bring together different areas and then try to see a cohesive way of uh, determining that. And then once we have that, help to predict what's going on. And that's the idea. The predictive capability is eventually is going to be helpful. Uh, is the one that helps, right? What's going to happen in the future, the time. We don't know yet. But if there is an algorithm that tells that, okay, future, this is going to happen, and we can test it, that will be a very, very useful algorithm. And that's what we are aiming to come at. And anyway, we'll come back again with hopefully all of us, especially Laszlo and Christopher, on the uh, on the 12th of uh, July. Okay, till then, thank you very much.